Hi, I'm Steve Jones and I'm going to tell you a little of the definition of magnetic domains. Now, magnetic domains don't exist in every substance. It only exists in ferromagnetics. That is, from the ferro you can see they're based on iron, so they're iron and steel. So they're in this type of magnetic. There are other materials, not just iron. But within the material is divided into these lumps that we call domains. And obviously there is a domain border, which we'll talk about in a minute. But within these domains, unlike in other materials, the individual atoms and the magnetism of the individual atoms is aligned in the same direction as each of these domains. Now, when there is no magnetic field applied, it doesn't really matter, because the thing isn't magnetic anyway. All of these domains cancel each other out. No matter how big they are, they still cancel each other out. There are as many in this direction as that direction, and so forth. And it's exactly the same in other materials, where all of these might be individual little atoms, but they're all aligned in different directions and all cancel each other out, so they're not magnetic either. But in these natural ferromagnetic materials, there are large lumps, and as soon as you put them into an applied field, it's not just one of the little atoms is going to realign itself, it's a whole domain. And when placed in an applied field, you can actually hear them as they click into line with the field. And this is a very strong effect. So there are no other magnetisms around to persuade them not to turn in this direction. They suddenly click into that direction until they're all aligned with the applied field. A very, very strong magnetic effect. So these domains obviously are fairly large. They are physically fairly large. The boundaries, sometimes the domain here will snatch a few from this one. If this is particularly strong, it'll pull a few from this one, and maybe some will disappear and some recreate. But overall, as soon as that applied field is there, then suddenly you get all of these domains snapping into order. When you take away the field, of course, there's going to be a tendency for them to remain where they are until something jogs their memory that they're not in the right orientation. Usually that is thermal energy. It gets the warmth that actually makes them demagnetize. So this is basically the definition of magnetic domains.